what I'm going to do is I'm going to go through a few questions with you guys to show you how we use this method. So let's have a go at this first question here. Okay, this first example. This is the exact same example up that we had at the start of the lesson that I showed you, but here we've got a question that involved as well. So here we've got this shape, this trapezium. We've got the three sides, 20 meters, 11 meters, and 13 meters. Let me just rewrite 13 a little bit better. There we go. The question asks us to find the perimeter of the shape. So here, the question is asking to find the perimeter. Now, if you remember what is from previous years and also what from year 7 and 8, we looked at shapes, and in particular, we looked at this thing called the perimeter. Hopefully you can remember that the perimeter is the total length around the outside of the shape of a 2D shape. So here we're looking for all these side lengths. So if I labeled it in the same colors that we did before, hopefully I remember what they were. 2, 3, and 4. I want to find all these side lengths added together. Great, so if I want to find the perimeter, I need to find all these side lengths added up together. But I need to find first what this missing side length is. Now, at the start, I already told you how we can do this. What you need to notice here is that, well, this side length is exactly the same as this length over here. If I draw this vertical line here, this vertical line here is going to be the exact same length as that purple side length. So if you have a look here, I'm going to just move this just so we can see that. If you look, they match up, they're exactly the same length. And the reason why I'm going to find this length here is because if you look here, in this part of the shape here, this forms a right angled triangle. We've got a right angle at the top there. And so we've got a right angle triangle, and what we can do is we can apply Pythagoras' theorem. So just remember, with Pythagoras' theorem, we can figure out what the side lengths of, we can use it to figure out the side lengths of different sides in our triangle. Now let's have a look at this right angle triangle here. And I'm going to draw this right angle triangle off to the side here. So I've got a right angle there. I've got 13 meters there. Now that red length, which is that vertical length over here, I don't know what it is. So I'm going to label that as x. I don't know what that value is. Now with Pythagoras' theorem, we need all three. We need the two of the other sides. So we also need this top length over here. But we might be looking at that if we have a look at our diagram, do we know what that length is? Well, they don't tell you what that length is. They tell you that whole top side is 20 meters long, but we don't know just this section, what that would be. However, if you have a look at the diagram, we have a way of figuring this out. If you have a look, this length in the top there, that is just going to be my top length minus my bottom length. If you notice, I've got these two lengths parallel to each other. These two. And so if I subtract the two from each other, I will actually get that top length. And so here I'm just going to do, this is 20 minus 11 meters, which will give me 9 meters. Because I take the length of the top side and subtract it from the length of the bottom side. Because if you have a look at the shape, that's what the two lengths are. Okay, cool. So I've got 9 meters at the top. Now I'm going to apply Pythagoras' theorem for this triangle here. So let me apply Pythagoras' theorem. First thing, I'm going to identify which one is my hypotenuse. So if you have a look, the hypotenuse, which side is it? Well, it's the side that's always opposite my right angle. So my right angle is over here at the top. So this 13 meters is going to be my hypotenuse. So here I'm going to have C is equal to 13. X, my missing side X is one of the shorter sides, and my other side is 9. So I'm going to label B is equal to 9. So let's write Pythagoras' theorem to actually find this missing red side first before we can actually do anything. So here we go. C squared is equal to A squared minus A squared plus B squared. I'm going to substitute my values in. I've got the value of C, my hypotenuse is 13 squared, is equal to my missing side. I called it X, so I'm going to write here X squared plus my value for my B is 9, so 9 squared. I'm going to rearrange this for my X squared. So here I'm going to just move my X squared to the other side. So I've got X squared is equal to 13 squared minus 9 squared. Okay, cool. Now that I've done that, I'm going to figure out what 13 squared minus 9 squared is. I can do that on my calculator. I'm going to grab my calculator out. here we go. For my calculator, I've got 13 squared minus 9 squared. Gives me 88. So there we go. I've got x squared is equal to 88. And what's the final step I need to do if I'm using Pythagoras' theorem? I need to take the square root. So I'm going to go x is equal to the square root of 88. And if I put that in my calculator, so I'm going to go square root 88. Gives me this long number here. So I'm going to just put it to 2 decimal places. So I've got that's equal to 9.38. And what's the unit for this? Remember, you need to include your units. I've been very clear about this whole year. Include your units. Okay, I've got 9.38 meters. So that's my length of x. Now, if you have a look at the question, am I done yet? I know that this side length over here, so this length over here, which is x, is 9.38 meters. And so that means that my purple side over here is also 9.38 meters. Am I done with the question now? Have I answered or solved what the question is asking me for? Well, if you have a look at the question, I haven't actually. The question is asking me to find the perimeter, and I said at the beginning, that's the total length around the outside of the shape. All I've done here is I've figured out what that missing side is. So if we want to answer the question, what I need to do is an additional step where I find the perimeter. So I'm going to go perimeter. I'm going to do P for perimeter. And all I'm going to do is if I'm finding the perimeter of a shape, I add all the side lengths together. So I'm going to go take my side lengths. So 20 at the top plus 13 plus 11 plus 9.38. So let's put that in a calculator. So I'm going to go 20 plus 13 plus 11 plus. I'm going to press answer just because I know that my previous answer was 9.38 and I don't want to round it off yet. So here I go. I've got 53.38. 53.38 meters. And at the end, I'm just going to write a quick summary. So the perimeter of the shape is 53.38 meters. Done. Okay. And that's how we apply Pythagoras' theorem to help us solve these types of problems. We first want to draw the shape. So I've already drawn this shape here for us. I would then want to identify where I can see right angled triangles. Then after I've done that, then I'm going to apply Pythagoras' theorem, label my sides, and then apply Pythagoras' theorem, and then solve the problem. So that's his first example here.